Arpit, can you hear me? This is Sonali Bharate.
Yeah, I can hear you.
Yes, I have an issue with week 2 assignment problem number 10.
Week 2 assignment, problem number 10.
Problem number
Yes.
10, yes.
Okay. Yeah. So, so the problem is like 2 drugs were tested on 10 and 12 subjects for lowering blood urea, and the data is given. We need to say at 95 confidence level which drug is better, right?
Yes.
Because we are comparing between 2 different populations, like 2 different samples, we'll use a t-test. Right, you have the solutions with you, right?
Yes, I have the solution with.
I'll just yeah. Can you see the solutions?
Yes.
Yeah, so for both the populations, they have calculated the average and the standard deviation. Then they have just directly put this formula for the t-test. So like here you have to, X bar here represents the mean. So the first will be the mean for A, second will be the mean for B. SP is the pooled variance of the samples, which is given by this formula. So N is like 10 for the first case and 12 for the second case. So NH will be 10, NL will be 12. S we are given, I think. Yeah, standard deviation we can calculate using the data points. Standard deviation is given. So you just put the formula and then calculate. Then you get a value for T. And then just look up the table. So here they have looked at both the 1-tail and 2-tail for the T table. And so even if we get a negative value for the T, we always take the absolute value. So plus minus does not matter. You just have to check if this absolute value of this is larger than or smaller than the critical value of the T. So in this case,
so how we have concluded that drug A is as good as drug B? The T calculated value is 1.67.
Okay. So when we do a t-test, we have, again, when we do any kind of test, we have 2 hypotheses, right? One is a null hypothesis, one is an alternative hypothesis. So the null hypothesis always assumes no difference. So in this case, when we are doing the t-test, the null hypothesis states that both the drugs are performing equally. So both of the drugs are similar. And the alternate hypothesis would be one drug is better than the other. And
yes,
using the T table, like using the degrees of freedom and the confidence level, we'll get a T value from the T table. And if the calculated value of T that we get is greater than one of these values, then we can reject our null hypothesis. In this case, it's not greater than both of them. So our null hypothesis holds. So our null hypothesis was both the drugs are good enough, equally good.
Yes. Thank you.
Yeah.
Thank you.
Yeah.
And the calculated values are also nearly same, sir.
Sorry.
The t values also are nearly same.
Yeah, see, I'm getting it.
Absolute and critical value.
Okay, when it is nearly the same, it will still be greater than or smaller than. Most of the cases, it won't come as exactly the same. If it comes as exactly the same, then also you reject, yes, accept the null hypothesis.
Sir,
Okay.
when we check single tail test, single tail value on the T table, or when we check the two tail test on the T table value?
Yeah. Okay. So let's say the same case, we are comparing activity of drug A and drug B. If you want to find out if there is a difference in the activity, does not matter if drug A is better or drug B is better, then we will use a two-tailed test. Okay, because the difference can be on either side. But if you want to find out if drug A is performing better than drug B, then we will use a one-sided test.
Sir, could you repeat once again? I have some network issue.
Yeah. So when we are comparing two drugs, so our null hypothesis is that both of the drugs have similar action. When we want to see if there is a difference in the action of one of these drugs, it does not matter which one of the drug is better, then we will use a two-tailed test, because a two-tailed test will tell us if there is a difference between the activity. But if we want a specific direction for the difference, so for example, if you want to say drug A is better than B or drug B is better than A, then we'll use a single-tailed test. Is that clear?
Yes, sir. Sir, I have a doubt on weekly assignment 2, question number 2.
Question number
So,
2. Okay. Question
sir,
number
how we calculate the Z value 1.05 in the assignment solution?
So the Z value will come from the Z table. We are given a P value. That is the probability. So if you look up the probability in the Z table, you will get a Z value.
So could you tell me how can we determine? So could you tell me how I determine the Z value 1.05?
Give me a second. I'll just open a table. Okay, can you see the table?
Yes, sir.
Yeah. So in the question, we are given a P value, which is 0.1469. So in the Z table, at 95% confidence interval, that is 0.05, we'll look at where the value is 0.1469, which is here. And we'll get the corresponding Z value, which is plus or minus 1. Both of them are same because the distribution is symmetric. So like if you have different tables, it might give slightly different values. Therefore, in the solution, the value is 1.05.
So the probability is 0.14. How can we use this?
So this is the p-value. In the question, we are given a p-value, 0.1469. In the table, everything here is a p-value. If we take like, 0.5, 0.05 confidence interval, we'll get a p-value. Like we'll see which p-value is given. Then we can get the corresponding z-value from here.
Okay, sir.
Yeah, so before we start, there were a few things from last class. So the first thing was the assignment 1. So one of the questions had 2 modes. Right. Ideally, the answer should be one of these 2 modes, but for the solution, what they have done is they have taken the mode that is closer to the center of the data. That was 14. So if you encounter any more questions of that sort in the course, then keep this in mind that even if there are 2 modes and you are expected to give the answer of one mode, choose the mode that is closer to the center of the data set. The other thing was, yes, calculators will be allowed in the exam. You'll be given a calculator, and I think a few weeks before the exam, you will be given a link to the online calculator so that you can familiarize yourself with that. You will also be given tables for like Z table, T table, and other tables, but you will not be given access to Excel. Is that okay?
Arpit
Yes,
ji, if Excel is not provided, then in multiple cases very tough to calculate by the calculator.
Yeah. Any
So
of the
question
questions
will
that
be
will be in
taken
the
care.
exam. Any of the questions that you will be given in the exam, you will be able to solve using the Z table, T table, and a calculator. You won't be
Okay,
given
thank you.
anything for which you will need Excel. Yeah.
Okay,
Yes,
thank you for
Seema. Yeah.
clarification.
Yeah,
sir,
Seema.
will we be given QCal? One of the sessions, the problems were solved using QCal, no? GraphPad, QCal
No,
calculator. Oh, okay,
I
okay.
don't think so.
So we have to
Yeah.
apply the formula. There
Yeah.
were three modes of solving the problem. One was applying the formula. Second was using the Excel sheet, and third was using QCal. So for the exam, we will only be given a mechanical calculator, so we will have to do it with the formula, right?
Yeah.
Okay.
I think you'll be given an online calculator, not a mechanical calculator. And I think it will have
Yeah.
scientific calculator options.
Okay, sir. Okay. Thank you.
Yeah.
I had a query. I had
Yeah.
raised questions on the video content of the lectures. I had
Okay.
raised it in the discussion forum and indicated the time points also, but I haven't yet had a response to it in the discussion forums I had asked.
Okay, I'll take a look at the discussion forum after class today.
Okay, fine. Because what sir has explained, in fact, because I had his mail ID also I had located, and long back I had corresponded with him from our college. So
Yeah.
I wrote to him also that these are the questions that I have raised, but I didn't get any response either from him or the discussion forum. So I just wondered, because like there seemed to be a discrepancy. And one of the questions actually I had asked was like, if suppose, I mean, it seemed as if like for the T calculations, minus 4.4, minus 4.4 was mentioned as greater than the table value of 1.7. Is it
That is
modulus
what.
that is considered?
So even if you get a negative value for T, while you calculate, you always take the absolute value while comparing it to the table.
So it is the difference, the modulus that is considered.
Modulus is considered.
I see. Okay, that was one of the questions is partially answered there, but there seemed to be a slight discrepancy in one or two places where n was 8. I think by a slip of the tongue he had mentioned it as 10 and the thing. So that if you could look into, I'll be really.
Yeah. I'll take a look at the discussion forum after class.
Right.
Okay. Okay, so we'll start today. We'll solve a assignment that is similar to the third assignment, which you have to submit now. So yeah, the first question is the effect of a new drug to reduce the glucose levels of monkeys with reference to an existing drug using the same monkeys is being tested in clinical trials. The difference in reduction in glucose level with old and new drugs are -4, -3, 5, 6, 5, -4 at P of 0.05. So we have to choose an option which is like, is the new drug better? We cannot judge which is better. The new drug is worse, or both of them are equal. So in this case, we'll do a t-test to find out if the drug is better. So the data set we are given is -4, -3, 5, 6, 5, -4. The p-value is 0.05. So for the formula for the t-test is x bar minus mu naught by s divided by root over of n. X bar will calculate is calculated as the mean of the data set, which is quite straightforward. You just add all the numbers and divide by n, which comes out to be 0.833. Mu naught will be 0 because we are comparing this to a distribution with mean of 0. So we are comparing the difference distribution with a distribution which has the mean of 0 and a standard deviation of 1. So the variance we need to calculate, standard deviation we need to calculate, which is given by summation of x minus x bar divided by n minus 1. Okay, there is a summation here, whole root over, which comes out to be 4.956. Then we can put all these values into the formula to calculate the t value, which turns out to be 0.4117. The degrees of freedom will be n minus 1, which is 6 minus 1, 5. We check both the t tables for one-sided and two-sided test. We see that the t values in both the cases are greater than the t value that we have calculated. So we can say that both the drugs are working equally. One drug is not better than the other. So the answer here will be option D.
Sir, we have to check the both one tail value or two tail value. T.
Yeah, so because the options are new drug is better or worse, so it's always better to check the two-sided thing to see if there is a difference. And if you find a difference, then you should go for a one-sided test to see which direction the difference is in. Since nothing is mentioned, it's better to check for both. And in this case, like both of them fail. So in most of the questions, we'll do like this, like we'll test for both of them, two-sided and one-sided.
Suppose we have a situation where the null hypothesis can be retained in one tail, but cannot. They give different answers. Like it could be retained in one tail, but not in two tail, or vice versa. That kind of scenario, if we have, then what would be the answer in such?
Yeah, so that can happen sometimes. So it will mostly happen in a one-tail test, you reject the null hypothesis, but you can't reject it in a two-tail test because the t-value here is kind of, so let's say we calculated a t-value of 2.3 or something. In this case, then we would have accepted the null hypothesis here and rejected it here. So in that case, it will depend on the question. So if they specifically ask if drug A is better, then you go by the one-sided answer.
Go by
but
the?
if they ask,
sorry,
so if
I
they
didn't get.
specifically, if they specifically ask if drug A is better, then you just calculate the T value for one-sided and then you go for it. You say that yes, drug A is better. But if they ask you if there is a difference, then you go for the two-sided thing and you say there is no difference.
Okay.
Yeah.
You'll have to
But-
select the option that is closer. But of course, we hope that something on the borderline doesn't come like that. Yeah.
In most of the cases, they won't ask you something that is like that.
Yeah. Because this is too much on the borderline.
Yeah. So the second question is, in a clinical trial 1, a drug X was tested with a placebo, and it was found to be better than the placebo with a p-value of less than 0.05. In clinical trial 2, a drug Y was tested with placebo, and it was found to be better than the placebo with a p-value of less than 0.01. So we have to choose which one of the options is right. So the first option is drug Y is better than drug X. Second option is drug X fails in the treatment 5% of the time. Third is drug X is effective 95% of the time and drug Y is effective 99% of the time. The fourth option is we can say with more confidence that drug Y is better than the placebo. So here the answer will be D, which is we can say with more confidence that drug Y is better than the placebo. Since these are separate clinical trials, we cannot directly compare the action of drug X to drug Y. So we cannot make any such statements as drug X is better than Y or drug Y is better than X. For the other two options, since we are not given the exact p-values, we don't know whether, so if we are given that the p-value here in the first case was 0.05, then we could have made a statement like drug X fails in the treatment 5% of the time. But since the p-value is less than 0.05 and we don't know what it is, we cannot make this exact statement. The same goes for option C. Is that?
Good evening, sir.
Yeah. Good evening.
Sorry, sir, I just joined now. May I know that which assignment week we are on discussion now?
Yeah, we are discussing questions similar to assignment 3.
So, sir, week 2 assignments have already been talked about.
Week 2 assignments, my colleague discussed in the last class, I think. If you have any doubts, you can ask it at the end of it.
So, but last time we were not able to join the meeting.
Yeah. The videos will be uploaded for all of these sessions.
So, sir, regarding that, sorry to disturb all of you. I have one doubt that last week's week 2 assignment, the due date has already been over because it was 8th. I have not submitted it. So, whether I would be eligible for the next week or to continue the course?
Yeah, you can continue the course.
Because now assignment 2, the answers have already come out.
Yeah, you cannot submit assignment 2, but you can continue with the course.
Okay, sir. Okay, sir. Thank you.
Yeah. So the third question is, two FDA-approved polymers, A and B, are used for drug encapsulation, and the results are given here. So like milligram of drug encapsulated per gram of polymer. Yeah. So we are given values for A 19, 19, 20, 21, 19, and for B 18, 18. Yeah.
Excuse me. Second question answer is what, sir?
Yeah. Continue. Hello.
Yes.
Yeah. Continue. You were saying
Second
something.
question answer is what, sir?
Sorry.
Second question answer is what?
Second question. So second question answer is D. Since these are two different clinical trials, we cannot directly compare the action of drug X and drug Y. So we cannot make a statement like drug Y is better than drug X. And since we are not given the exact p values, we cannot make statements B and C either.
Okay, sir. Thank you. Thank you very much.
But sir, in that question.
Sorry, I can't hear you. Hello?
Sir,
Yeah.
I have a regarding option C because with 95% confidence, we can say
Yeah.
that drug X is better than placebo, no? As it comes in the clinical trial.
Yeah, because
And
continue.
So as per the question, it is with 95% confidence that we can say that drug X is better than placebo, and in second trial, with 99% confidence, we can say that drug Y is better. So why can't the answer be C?
Yeah, so here we are given like the p-value is less than 0.05, but we are not said that the p-value was equal to 0.05. If you had said that the p-value is equal to 0.05 here and equal to 0.01 here, we could have said that the drug X is effective 95% of the time and drug Y is effective 99% of the time. So in this case, the p-value can be for drug X can be 0.03, in which case it will be effective 97% of the time. But we don't know whether the p-value is 0.03 or something else. So we cannot like make this statement.
Clear.
Yeah.
Okay, it's clear.
Yeah. Moving on, yeah. So we are given the values for A and B. We are asked like what is the total sum of squares for this data set and what is the mean total sum of squares. Yeah, so the total sum of squares for the data set is given as x minus x double bar whole square sum of this, where x double bar is the overall mean of the entire data set and x is each data point. So we can calculate x double bar by like summing all the data and dividing it by n, which is 10, which comes out to be 19. And to calculate the total sum of squares, all we need to do is subtract each individual data point from 19, take the square and sum it over, which comes out to be 8. The degrees of freedom for total sum of squares is given as n minus 1, which is 10 minus 1, which is 9. So the mean total sum of squares will be total sum of squares degree divided by the degrees of freedom, which is 8 by 9 or 0.889. Is this clear?
Just to make sure that I've understood it right, that is, first we have to calculate the mean of all the values given there.
Yeah.
I think this particular topic I'm yet to just get to. So
yeah, this
that's
is ANOVA.
Yeah. So total sum of squares would be x minus x bar the whole squared summation of this.
Summation of this.
Okay. So that is I think the TSS would be each x value, individual x value minus the mean.
Overall mean for the entire
Okay.
data set. Yeah.
Overall mean. The sum of that.
Sum of the squares. Yeah.
Okay, fine. Only sum of it. Okay, fine. Yeah.
Yeah.
And degrees of freedom and mean total sum of squares is TSS by DF. Okay. Okay, fine. Sum of squares. Fine. Thank you.
Yeah. Yeah. So for question number 4, like with respect to question 3, what is the value of t? So the t value is given by this formula, which was also there in the second assignment. So is the mean of A minus mean of B divided by the pooled standard deviation multiplied by root over of the inverse of the number of samples. So the pooled standard deviation is given by this formula. We know that for A, the average is 19.6 and for B, it's 18.4. So all we did was sum all of these values and take the divided by 5 in each case. Then standard deviation also we'll calculate using the standard formula, which is x minus x bar by n minus 1 whole root over. So I have not calculated those here because it gets a lot more tedious. So yeah, you can do that and you'll get these values. N value in both case will be 5. Then we'll find xa bar minus xb bar, which comes out to be 1.2. We calculate the pool standard deviation, which turns out to be 0.7415. And then we use those values to calculate the t value, which is 2.559. Is that clear?
Yes. Just a doubt on the earlier step. Degrees of freedom, it was n minus 1 as per the formula, right?
Yeah.
Degrees of freedom continues to be n minus 1.
Yeah. So in ANOVA, we have 3 degrees of freedom.
Okay.
So if we are taking the total sum of squares, that is, we are subtracting each data point from the total overall mean of the data, then the degrees of freedom is given by n minus 1, which is the total number of samples minus 1. If we are taking the error, sum of square of errors, in that case, what?
Okay.
Or the within group, sum of squares within the group.
Okay.
Yeah. So in that case, we are subtracting the data point from the mean of the treatment. So in this case, it will be for A, we'll subtract each data point from the mean of A. For B, we'll subtract each data point from the mean of B, square all those values and take the sum. So that is the sum of square of errors. In that case, the degrees of freedom will be n minus k, where n is the total. N is the total number of samples and k is the total number of treatments. So in this case, it will be a total number of treatments or categories. So in this case, it will be 10 minus 2 because we have 2 categories, A and B, which will be 8. And the other cases, when we take the sum of squares between groups, so in that case, we subtract the mean of each group from the overall mean. We take the sum of square and we multiply it by the number of samples in each group.
Fine.
In that case, the degree of freedom will be number of treatments minus 1. That will be 2 minus 1, which is 1.
Thank you.
Yeah, so here, as I talked about, we have to calculate the degrees of freedom of the error. So degrees of freedom of the error is given by n minus k, which is number of samples minus number of treatments or number of types of samples. So here we have 2 types of samples, but one is A, one is B. We have total 10 samples. So the degree of freedom of error will be 10 minus 2, which is 8. Last question is like, yeah, with respect to question 3, the results indicate that at 95% confidence interval, treatment B is better than A. Both the polymers behave in the same way. It is difficult to conclude, and A is better than B. So we calculated the T value to be 2.559. And yeah, because like while calculating the T value, we subtracted the mean of A from B, right? So we are comparing if A is, so here our null hypothesis is both of them are equal, and the alternate hypothesis is X is better than B. Sorry, A is better than B. So we got a T value of 2.559, and we do a one-sided test here because we want to check like if A is better than B or not. We like using the T table for 95% confidence interval, we get a value, critical value of 1.86. And here, since the calculated T value is greater than the T value for the one-sided test, we say that A is like better than B. Is that clear?
Yes.
Okay, I think yeah. These are the 6 questions. So,
sir, can we discuss the initial 3 questions as we have joined late?
Yeah, sure. So the first question, we are given like, yeah, continue.
Yes, sir.
Someone was saying something. Okay, yeah. So here we are comparing using the same monkeys, 2 drugs are tested, and we are given the difference in reduction of glucose level after taking each drug. At a 0.05 p-value, what can we say about the drugs? So we are given the data set. We know the p-value. We'll do a t-test to compare. So since we are given the difference of the means, we'll compare it to a null distribution, which has a mean of 0 and standard deviation of 1. So we calculate x bar. So the formula is x bar minus mu naught divided by s by root over of n, where s is the standard deviation of our data set, n is the number of samples, x bar is the mean of the data set. So we can calculate the mean straightforwardly, sum it up and divide it by n, which comes out to be 0.883. Mu naught here is 0. We calculate the standard deviation by, so here it will be a summation of x minus x bar is summation of x minus x bar whole square divided by n minus 1 whole root over. Yeah, we do that, we get a value of s 4.956, and then we input all of this into the t value calculation, and then we get a t value of 0.4117. So then we see the t tables for both one-sided and two-sided. We get a t value at 0.05 confidence level. And we see that the t value in both of the cases is greater than the t value that we have calculated. So we have to accept the null hypothesis, which is that both of the drugs are working equal. Like there's no difference.
Sir, mu 0 is 0. How is it?
Yeah, so in this case, we are given the differences of the difference in the reduction of glucose level. So imagine we were given the reduction in glucose level in this case. So we would have been given 2 data sets for each of the drugs, which is the case here. So we would have got something like this. In that case, we would do a proper t-test like this. We'll use this formula, use the sample pooled mean, pooled sample standard deviation, and calculate the mean for each data set and use it. But since we are just given the differences here, we have to compare it to a null distribution with a mean of 0 and a standard deviation of 1. So in that case, the formula turns out to be this.
In
This is
case
basically a
the
one
t
sample
calculated, in
Sorry?
case the t calculated is greater than the t from table, what we should do?
Then we will reject the null hypothesis. And if we are doing it, so if the t calculated is greater than the two-sided t value, then we'll say that there is a difference in the action of both of the drugs. And if it is greater than a one-sided t-test, then we'll say the drug A is better than drug B. Okay. So if the t calculated value is less than the t value from the table, then we say that we can't reject the null hypothesis and both of the drugs are working equally. Is that clear?
Sir.
Interestingly.
Yeah.
Sorry.
Sir, what is that means? I didn't get that mu 0 is actually what does it stands for? Means it is 0, but I didn't get from the question why.
Yeah, here, so we are comparing the differences. So it doesn't matter. We could have just written the mean here. So this is a one sample t-test. We could have just written the mean and ignored this part. But yeah, we are basically comparing this distribution to a null distribution, which has a mean of 0 and a standard deviation of 1. So instead of comparing two different distributions, we are comparing this to a baseline distribution.
But we are comparing here old drug and the new drug.
Sorry,
we are comparing the reduction in the blood glucose level in one old drug and one new drug. So obviously
we
there
are
is
comparing we have the differences in reduction. We don't have the reduction values for each drug. If we had the reduction value for each drug, we would have done a 2-sample t-test, in which case we would have found data like mean for the different data sets individually and calculated a sample standard deviation and then use the other formula. Since we are given just the differences, we compare it to a base distribution.
okay, sir. Okay.
You know, it is a little, I mean, I hadn't seen the t-value for the two-sided, two-tailed distribution at 0.05 p-value, that is 95% confidence interval. I find that the table value of the t-value for the two-sided, I meant to say two-tailed distribution is 2.5, and for the one-tailed distribution, the table value is 2.015. In what you have calculated. Interestingly, I mean, I know we are not supposed to give the answers for the present assignment, but well, there is an instance where the calculated value is falling between these two, exactly midway between these two. We are faced with the task of, selecting from the 4 options.
The first question, is it?
Yeah.
Arpit, the new question is, what is the answer if our obtained value is between two-sided t-value tabulated and one-sided tabulated t-value?
Yeah, see, here the options are the new drug is better, new drug is worse, cannot judge, and both are equal. Since you are specifically given options of one drug being better than the other, you can use the one-sided t-value to get your answer.
Yeah.
So if you can say that one drug is doing better than the other, then you can select that option.
Because unfortunately, there's an option called cannot judge, which, people may tend to choose because, it's midway, it's on the borderline.
Yeah.
And
I think it's better to choose.
Next question is related to this one-sided. I am have some confusion regarding lower side A to A equal to B. Very easy to interpret, and null hypothesis not equal to A is not equal to B. But when we see one-sided A greater than B or B greater than A, at that particular juncture, I am like confused. Okay, how we should decide?
Okay, so in this case, what we did was we subtracted A from B, right?
Yes.
And we got a t-value, which was greater than the critical value.
Okay.
Since we subtracted A from B, we know that action of A is greater than action of B. And
I got my answer. Okay.
Yeah. If we got a negative value here, minus 2.559, and we did a one-tail test, which was significant. Since it is negative, we would have said that drug B is greater than drug A.
Okay.
Because the direction would have changed.
Yeah.
Okay, I have one doubt where we can find the video link of these discussions.
Video?
Or the discussion of last class. Unfortunately, I missed the discussion of.
Yeah. So currently the videos are in the chat for this link. I'll upload them in YouTube by next class and I'll give you guys a link. Is that okay?
Okay.
Yeah. Yeah, so the second and third question also, no? So the second question was like drug X was tested with placebo in a clinical trial 1. It was found to be better than the placebo with a p-value of less than 0.05. Similarly, drug Y in a second clinical trial was found to be better than placebo with a p-value of less than 0.01. We have to select the right answer. So since both of them are independent clinical trials, we cannot tell if one drug is better or worse than the other because there was no direct comparison. So we can't say the statement A. since again, we don't know the exact p values, so we don't know how much like x, the chances of x failing and the chances of x being effective, also the chances of y failing and being effective. If we were given an exact p value of, let's say, p is equal to 0.03 for x, we could have told that the drug x fails 3% of the time and is effective 97% of the time. But since we are not given those values, we cannot also make statements B and C. We can only say that with more confidence, drug Y is better than the placebo, because the p-value for drug Y was less than 0.01, and for drug X, it was less than 0.05. The answer here will be D.
So with respect to p-value, we have to compare the drug.
Yeah.
So in case it was drug X, the p-value is less than 0.05.
Yeah.
That means
so if we are given an exact p-value, so let's say if for drug X we are given a p-value of 0.03, we would have told that drug X is effective 97% of the times and it fails 3% of the times. But since we are not given any exact value, all we can say is like this thing, that drug Y is better than the placebo or drug X is better than the placebo. So in this case, we can say with a 95% confidence that drug X is better than placebo. In the second case, we can say with 99% confidence that drug Y is better than placebo. So the final statement that we can say is we have more confidence that drug Y is better than the placebo.
okay, sir.
Doesn't this state that drug Y is better than drug X?
Not really. So we know that the p-value for drug X is less than 0.05, but we don't know whether it's greater than 0.01. That's why the statement is like we can say with more confidence that drug Y is better than the placebo. We cannot say that drug Y is better than drug X, because the p-value for drug X can also be 0.001.
Okay, sir. Thank you.
Yeah, in the third question, we are given two data sets for two polymers. We are just asked to calculate the total sum of squares and the mean total sum of squares. So for total sum of squares, all we have to do is find the mean for the whole data set, subtract each data point from the mean, square it, and take the sum. So the mean is straightforward, calculated as sum of the data points divided by number of data points, which turns out to be 19. Then we use this formula to calculate the total sum of squares. So each data point we subtract from the mean, take the square, and then we sum it all over. And we get a total sum of squares of each. The degrees of freedom for the total sum of squares is given as n minus 1, which is 10 minus 1, which is 9. And the mean total sum of squares is given as total sum of squares divided by degrees of freedom, which is 8 by 9 or 0.889. Is that clear?
Okay, sir.
Does anyone have any doubts in this assignment or in the first two assignments?
Sir, in week 2 assignment, can we go on a discussion for types of problem like first and the third one?
First and the third one.
Yes, in week 2, based on the same lines, where we have
Based
to
on
calculate 95% the
yeah. Yeah. So can you see the screen?
Yes, sir.
Yeah. So the first question is the mean diameter and standard deviation of tubes manufactured in a company at 12 centimeter and 1 centimeter respectively. So 95.4% of bolts will have a diameter between, and these are the options. So we know 95.4% of data falls under two standard deviations. Right, area of the curve under minus 2 sigma to 2 sigma is 95.4%. So all we need to do is subtract 2 standard deviations from the mean on both sides and we'll get a range. So that is 12 minus 2 into 1 and 12 plus 2 into 1, which is 10 and 14.
Sir, but 95%, 95.4%, it means 1.966, no?
You don't like, that's true for a standardized distribution. 95% is 1.96, 95.4% is 2, I think. And I think it's for T distribution that you're seeing, right? So in
So
this case, we are assuming that it's a normal distribution.
Nothing has been mentioned about the kind of distribution. No?
Yeah, then we just assume it's a normal distribution.
Nevertheless, rounded off, it works out to between 10 and 14.
Yeah. T distribution, I think, yeah, you'll get values which are slightly different, but almost always you'll round it off to 10 and 14. In the solutions, I think it's not clear, like the way they have calculated this. It's kind of confusing.
Yes, that is why, sir.
Sorry?
Yes, that's why on the looking on the calculations, I was having that.
Yeah.
Picture.
You don't need to calculate a lot. You just know that 95.4% of data is between 2 standard deviations. You know the standard deviation, you know the mean. So you just have to subtract it and add it to the mean to get a range.
Solutions have been uploaded?
Yeah, they have been uploaded.
I see. Okay. The same link, is it?
Yeah. In week 2, after the assignment, you find solutions. Here.
Okay. Yeah. Oh, I see. Oh, I didn't notice that. Thank you.
Yeah. So, yeah, with the second question is, you wanted the second or the third question?
Sir, both second and the third.
Oh, okay. So with respect to question 1, if the probability of occurrence of a bolt of certain diameter is 0.1469, what is the diameter of that bolt? So again, we are assuming a standard normal distribution. We are given the mean and the standard deviation, which is 12 centimeter and 1 centimeter. And we are given a probability, which is a p-value. So we look up the z table and we get a z value for the probability. Then the z value turns out to be 1.05 and we just put it in this equation to find x. As I was telling before, so at 0.05 confidence, you can check the p-values and you arrive at a p-value which is given 0.1469 and then just check which z value it belongs to. That's how you get the z value from the p-value. Is that clear?
Okay.
Yeah. For the third question, it's just directly asking calculate the standard error for the following sample. So all we need to do is like find the standard deviation and then divide it by root of the number of data. The standard deviation you can calculate using this formula. 1 by n sum of the data points minus the mean of the data whole square, and then take a whole root. It's mostly calculation. Direct formula. Any other question?
Sir, if we are performing a 2 sample t-test, in that question 5, the answer which they have accepted is that null hypothesis mu A is equal to mu B. So why not the third one? Because they have stated it that A new drug B
Question
is
number
tested
5.
against. Yes. The same one which you have highlighted.
Yeah. So the question is, a new drug B is tested against an existing one, and it is proposed to introduce it only if it's better than the old. What should be the null and alternate hypothesis? So here we are specifically stated, like, we have to check only like if drug B is better than drug A, only if it's better than the old. So our null hypothesis anyways will be both of the drugs act equally. So action of A is equal to action of B. So the alternate hypothesis should be, is B better than A? So like mu A is less than mu B. If you choose the third option, you are seeing if there is a difference. You are not saying if one drug is better than the other. Right.
Okay, sir.
Is that clear?
Okay, sir. Okay. And if the above one on the same line, the problem if the coefficient of variance of two populations.
If the coefficient of variation of two populations are same and the ratio of mean of population 1 and 2 is 1:3, what is the value of standard deviation of population 1 divided by population 2? So coefficient of variation is given as sigma by mu into 100. So this is the formula for coefficient of variation. So we know that coefficient of variation of both the populations are same. For the first population, we say the sigma, like standard deviation, is sigma 1, mean is mu 1. For the second one, it's sigma 2 by mu 2. And if you just equate it and then transfer sigmas to both one side and mu to one side, you see that the ratio of standard deviation is equal to ratio of means, which is given as 1:3. Yeah, given the ratio of mean is given. So ratio of standard deviation will be equal to ratio of mean, which is 1/3 again.
Can I ask a question?
Yeah, sure.
Sir, I wanted to know, you just now told that the recordings of these will be shared. It was not clear. Can you repeat it again? Where can I find the recordings of all these problem solving videos and other things?
Yeah, so
because for some personal reason I missed it. Now I'm catching up. That's the reason.
Yeah. So we are supposed to upload it on YouTube. I have not uploaded it yet. Once I upload, I'll share the link. By
Where will
next
you
class,
share
I'll share a link.
Where will you share? How will I get it, sir? By mail or by, should I check it in the announcements?
Because I don't have any method to share it. I'll just post it on the discussion forum. Does it work?
So you should, if you post it on announcement, I think we'll take it up from, take the links from there.
I'm not sure whether, I'm not sure whether we can post it on
Yes, sir. I also agree to madam. You means if it is in the announcement, everybody gets to know it, because in the discussions, we are not every time looking into discussions and forums in the workplace or other places. Hope you can understand.
Or maybe you can create a folder in the ask the question, sir. You open that ask the question, this thing.
Okay, yeah. I'll ask. We are not given access to the announcement, so I don't think we can make any announcements. I'll just ask the team if they can make the announcement. Else, I'll just put it on the discussion forum, and as far as possible, you can let other people know.
Sir, you can put in the ask a question discussion forum, that for this thing folder, sir.
Yeah.
I think you can create a folder there because it is linked with Google. Sir, here it is conversation 24 about. Sir, there you can create a folder there. Put it, sir.
Yeah, I'll look into that.
Yeah, please. Thank you, sir. Thank you so much.
Yeah. Arpit, one more question. Whatever the solutions right now available on the wave, that should be remain on that till examination?
Yeah, I think that will remain. You can also download the solutions.
That's why I am asking. Is it remain? Then we should not download. Else we need to download.
I think it will remain, but just in case, you can also download.
Okay, thank you.
Yeah, I think they won't change it anymore once the solutions are uploaded, because it will be uploaded after the due dates of the assignments. No, so yeah, I don't think they'll remove it.
Sir, another question from week 2.
Yeah.
I just want the conceptual understanding of this. They've asked that if you want to increase the type 1 error, where P is the probability mentioned, what should you do with the P value? The question number
6.
6.
To increase type 1 error, what should you do? So yeah, you can see here, right? So the part here highlighted in red is the type 1 error, which is like your alternate hypothesis is you are just a second. Your null hypothesis is false, but you are not rejecting it. Type 1 error. Yeah. Type 2 error is your null hypothesis is true and you are still rejecting it. Yeah.
Type 2 error.
Yeah. So type 1 error is given by this area, this red portion, right? And this line that you see, that is your cutoff for p-value. Generally, this value is set as 0.05. So if you want to reduce the type 1 error, you want to reduce the area that is to the right of this value. So what you need to do is you need to increase the p-value so that the area here will decrease. Is that clear? Hello.
Sir, won't it be means like you have to decrease the p-value because type 2 error?
We're talking about type 1, no?
Yes, I'm talking about type 1 error, but okay, sir.
9 and 10, assignment 2. Will you please explain?
Which question?
Question number 9 and 10.
9
Assignment
and
2.
10. Okay. Yeah. So question number 9 is a company is manufacturing artificial tendons whose average tensile strength is 10 millinewton per meter square. When we take 10 samples and measure their tensile strength, the mean comes out to be 8 millinewton per meter square. If you want to conclude that the sample comes from the same population at 95% confidence level, what should be the minimum standard deviation of this sample set permissible? Okay. Yeah. So for the population, we are given the mean, which is 10, the tensile strength, which is 10. For the 10 samples that we collected, the tensile strength is 8. We want to calculate the minimum standard deviation of the sample state. Minimum or maximum? Should be the minimum, yeah. Minimum standard deviation of the sample set that is permissible. So yeah, we do a t-test at 95% confidence interval, where we know the population mean here is 10. We compare it with the sample. So we know the X bar, which is sample mean. We want to know S, which is the standard deviation. We know the p-value at 95% confidence interval. So using a two-tailed test at 95%, we get a t-value of 2.262. Then we just put all of this and we get a S value. So the standard deviation value we can calculate using this formula. Is that clear?
Yes.
Yeah. So the 10 question. 2 drugs are tested on 10 and 12 subjects for lowering blood urea. The data is given below. At 95% confidence level, what can we say? Drug A is as good as drug B, drug A is better than drug B, drug A is worse than B. A and B are not good. Okay. So we are given the average values, which are the means and the standard deviations for both these tests. We need to do a t-test, 2-sample t-test to compare between both of them. So we know the mean values, we know the n values, 10 and 12. We know the standard deviations. We calculate the pool standard deviation using this formula. We get it as 0.193. We calculate the difference between the means, and then we just do the t-test. We see that the t-value we get is less than the critical t-value for both one-tail and two-tail test. So we can say, like, as the t-value is less than the critical value, we say both of the drugs are as good as each other. So the null hypothesis holds.
Hello. So these type of problems are given in which session? In which lecture? Lecture number 5 or 4?
Which sample?
In which?
This type of questions.
Same type of.
I think it's something around.
I think it's in the t-test. One of these 2 videos.
7, 8.
Should be there.
Number 6, 7, 8 about it is.
Yeah.
Okay. Thank you.
Just one query. When they say X bar H and X bar L, I took it to, initially I was thinking that it would mean the higher and the lower values, H for higher and L for lower, like that. But in the lecture, Professor mentioned that it just refers to value 1 and value 2, like that.
Most of the places they write X1 and X2. So it's just convention. I don't know why they have exactly used H and L.
H I thought was the higher of the 2 values and L was the lower, in fact. I thought initially, then
that you can reverse it. That's not an issue.
Because I found it makes a difference to the final value.
It will just be positive or negative. But the value should be the same. Like the absolute value should be the same. It just should be like one is positive, one is negative.
Okay.
Are you finding different values?
Actually, for this 10th problem, I did calculate it and I did find a difference when I used the first, that is when I used XH and NH as corresponding to the higher of the 2. That is, there's a difference, because the NH may not correspond to the higher of the 2. Yeah, this was the same one. Yeah, higher of the 2 items or the numbers in the distribution, that is N corresponding to the number of items in the distribution. Because even in the way they have worked out the problem, if you see 1 by NH is coming as 1 by 10 and 1 by NL is coming as 1 by 12 when 10 is the lower of the 2. And I took it to mean the higher under N and the higher corresponding to X bar. That's how, and I. Difference.
Sorry.
Huh.
So, if I am understanding you correct, you used XH as the higher mean, that is 1.3, and NH as the higher standard deviation, which is 0.15.
Yes, and then NH.
Okay. No, so that is wrong. Yeah, that so here H is like, I don't know exactly what H and L here mean. We generally, like, when I studied this course, we used to write 1 and 2. So like every time you use, so for XH, if you have taken the average of 1.3, then for NH, you have to take the average of take the standard deviation from the same population, which is 0.13, not the higher value.
Okay, yeah. So I worked it out that way. After, I mean, something in some point after working it out according to the higher and lower interpretations of mine, I listened to the lecture once again, and I found that professors mentioning sample 1 and sample 2. So I took it as corresponding to the respective one. Then I got the correct answer as what gave. Otherwise, I was getting a different answer.
Yeah, H is one sample, L is one sample. It does not mean higher or lower.
Okay, yeah.
Yeah.
Sir?
Yeah.
Sir, in week 1, question number... Week 1,
question number?
5. Sir, so after solving the question, answer was 23.4.
Yes, sir. The answer was 23.4.
Just a second.
Yes, this is true. 23.4, whereas the accepted answer is coming as 24.
So generally, sir, they give in the range. So it should be 23, 24, but this time only they gave the answer 24. So many of us have got wrong.
Yeah.
So you got 23 point something.
Yes, sir. In solution also they mention 23.4.
Yeah, but see, the question is, what is the minimum number of patients required to? So you can't have 23.5 patients in a trial,
No, sir,
right?
if we consider 23.4 as 23, then it should be correct.
You can't consider it as 23 because you need something greater than 23.
Okay.
So the minimum
23.4 can't be rounded off to 24.
No.
If it would have
You will
been
always
24.
round it up to the next value.
But then 23.4 will be rounded off to 23, isn't it?
Yes.
No. You're not. So if you have 23 patients, you can't get a confidence of 95%. You need 23.3 or 23.4 patients, right? So for that 0.4, you need one more patient. Every time you get a question like this, where you are asked the number of patients or the number of samples, and you get a point value, which you are expected to round off, never round it down.
Okay.
It should always be rounded up.
Hello, sir. Sir, in the first assignment,
yeah,
and the 10th question was found to be 0.9545.
0.954. Yeah.
And in every video, means in the videos of Doble sir, he would always say that answer is like to 95.45%, 9%. I just wrote there 95.45 in the percentage. So it came out to be wrong. So in final examination, there will be like 4 options, or we will have to enter the answers manually?
See, in the 9th question, you see, they have asked what percentage of the area. In that case, you can write a percentage. If they don't ask the percentage, like in question number 10, you have to give a exact fraction value, like decimal value.
Okay, sir. Thank you.
Yeah.
So week 3, question 1. Can I have an explanation again for that?
Week 3.
Question number 1. Where we are testing the efficacy of a new drug to reduce the.
Yeah. Yes, so because you have not submitted this, I'm not allowed to discuss the answer to that. I have a similar question.
Yes, on the same line.
Yeah. So the question here is effect of a new drug to reduce glucose level is tested. We are given the differences in the reduction of glucose level values. So we are given the difference between both of the treatments, and at 0.05%, 95% confidence interval, what can we say? So we are given the data set, we are given P is equal to 0.05. We do a t-test. We compare it to a distribution of mean 0 and standard deviation 1. The difference distribution to a distribution of mean 0. So we just calculate this t value using this formula, where x bar is the mean of the data, s is the standard deviation, and n is the number of data points. X bar we can directly calculate, sum the numbers and then divide by n. Mu naught is 0. S we can calculate as difference of each data point from the mean, square of that divided by n minus 1. We'll take a root. That comes out to be 4.956. Then we put all these values in this equation to calculate a t value, which comes out to be 0.4117. Then we see the t table, two-sided and one-sided, and in both cases, the t value, the critical t value is greater than the value that we have calculated. So we cannot reject the null hypothesis. We say that both of the drugs are equal. So option D will be the answer here. Both of the drugs are equal. So you can solve the assignment 3 question in a similar way.
Okay, sir.
Yeah. Are there any more questions relating to all the 3 assignments?
The doubts on the video, be getting back via
on
the
discussion forum, right?
Okay.
Yeah, I'll get back to them on the discussion forum. So once I upload these videos also to YouTube, I'll put the link in the discussion forum and ask them to put up the link in the announcement. But I'm not sure whether they'll do it. So like on when they will do it. So just keep checking the discussion forum probably tomorrow or Monday. By Monday, I'll upload all these videos.
Sir, generally, hello, sir.
Yeah.
Sir, the previously I have attended some courses. So what they do is they create a tab, problem solving session tab, in which the links are available. So after the session gets over, they upload it. So the viewers can get directly from there.
Yeah, I'll look into that also. Yeah, as someone else pointed out, I can create a tab in that discussion forum also, right? I'll check that if possible. I'll put the links there also. Links or videos.
Sir, NPTEL team is connected by WhatsApp. They are sending reminder, so it will be.
I can't hear you. think there's some connection issue.
Team is connected with the WhatsApp group. They are sending us reminder for the problem discussion. So we can send the
Reminders
same
for?
link by the same way. So we get more easy. Sessions, problem solving sessions. They are sending us reminder for all these sessions by WhatsApp.
And how did you join the WhatsApp group? Was there a link?
Sir, I'm already joined with that. I got link many before, so I'm connected with NPTEL.
Sir, we don't know how the WhatsApp link is created, but we get the message. We are not in the group. I'm individually getting a message as a business account.
Yes. Sir.
Okay. Okay.
Yes, sir. We are individually connected.
So do you get all the announcements there also?
Yes, sir, we get.
Yes.
Announcements we don't get, sir. Only
No,
links
no,
we get.
sir.
And
Only links.
Only
you
the
get.
alert for the problem session.
Sorry?
Only the alert for the problem solving session comes on that NPTEL WhatsApp group,
Okay.
indicating
I'll talk to
that today.
them. I'll talk to them. We'll see if they can put the links there also.
In fact, last time I waited till about 8:30 to join that particular group. I mean, to join that particular session, and I couldn't. And I tried to communicate to the WhatsApp group, wherein this NPTEL announcement for the problem-solving session comes. It's evident that somebody has viewed it, but they couldn't do much about it. And it was only at 8:30 about that I could get connected to the session like this on which they were having on Google Meet.
Okay.
Same issue even I had.
Yes. So for due to that, I was waiting for the recorded session, but recorded session was not available. So I left the week 2 assignment, sir.
Yeah,
yes,
I'll upload this somewhere and give you the links. I'll try to do it in the announcement and WhatsApp group if
So
possible.
in fact, the timings for the change in session for this weekly discussion for week 2 was from, I guess the mail was from 6 to 8 p.m. But in spite of sending repeated requests for joining in the meet, there was no response.
Yes, that's true.
And that's
So
why
it was by
this
Zoom.
session they said it will be for
Last
6.
time we are connected. Zoom. Last time we are connected by Zoom.
Okay.
No, it was on Google Meet.
That I think
last time it was on Google Meet.
Not sure. They are unable to see us.
So was it for the same course, the other TA, that session, or was it a different course?
For biostatistics itself. Biostatistics and design of
Tuesday session.
Yeah.
Okay.
Tuesday session had the problem.
Okay, I'll talk to them. Yeah. So, yeah, I think for today we are done. Like, does anyone have any more doubts? This video thing and all, I'll figure out. I'll post the videos by tomorrow or day after, so that you guys can access.
Most of it I'm clear with now. Yeah.
Yeah. For your doubts, I'll look into the discussion forum. Yeah. Specific video related doubts you have read. Yeah.
Sir, also on the discussion forums, we can see a lot of people have given can you provide an explanation to this and this question? So also sometimes we also are having the same problem, but means I can't see the solution to it. Means it has been responded.
So if the due date is not over, I don't think they'll give you the solutions. But after the due dates, they will give you the solution. So mostly they shared the solution sheet, no?
That is about the Google Mail, where you can just open it and see, sir, where many people have about 46 conversations are there, for which there is no response by anybody. That is what sir is asking.
Yes, correct.
Okay. In the discussion forum itself, or is it somewhere else?
In the discussion.
I see 23 conversations. And yeah.
Because why I am asking this is because we don't need an answer, but just we need a guideline as to how the similar problem on the same lines should be solved.
Okay. So for the assignments, we'll do that in these sessions. We'll tell you how to solve similar questions. Apart from that, I think the discussion forum is also like looked after by some other people. I don't think they are sharing us solutions. Yeah, they just mentioned detailed solutions will be provided.
It is the column called as ask a question.
Ask a question, yeah. Doubts not quiz, introduce yourself. Okay, I'll take a look at this. I'll see. Yeah, there are a lot of questions. Yeah, my next class, I'll try to go through some of them.
So for the next problem solving session would be on Tuesday, right?
Yeah. Tuesday, 6 to 8, I think.
Okay.
Then we'll meet again next week, Saturday. Same time. Okay.